This video is covering the idea of complex numbers. Complex numbers are any numbers that are a form of a plus bi, where a and b are real numbers and I is what's called our imaginary number. I is represented by the square root of -1. Now that doesn't have, that is not a real number. That is, we know that taking the square root of any negative number doesn't have a real answer. So the square root of -1 is always going to result in I. So the first thing we're going to do is evaluate what each of these mean and find that they actually cycle through. So when we take I squared, that means I'm going to take the square root of -1 and we're going to square it. That means that's going to be eliminating my square roots and becomes -1. So this is one of those rare occasions where if I square something, it actually becomes negative. Well, let's look at what happens when I have I cubed. Well, I cubed is the same as I squared multiplied by I. So I squared we just said is -1 multiplied by I, which is just I, so it's negative I. Well, what about I to the fourth? Well, I to the fourth is I squared multiplied by I squared. Or we just said I squared is -1, so it's -1 times -1, which is 1. And what we're going to find is we actually cycle through these four items. We have I, -1, I, 1. Because if we look at I to the fifth, I to the fifth is simply the same as I to the fourth multiplied by I. Well, I to the fourth is 1. Oops. And I is just I, so I to the fifth is the same as I to the first. And then again, we can cycle through it all. I to the sixth is the same as I to the fourth multiplied by I squared. Well, again, I to the fourth is going to be 1, and I squared is -1. So 1 times -1 is -1. I to the seventh is the same as I to the fourth multiplied by I cubed. So we have 1 times -I, which is -I. And then I to the eighth is going to be I to the fourth multiplied I to the fourth. So it's I to the fourth, so 1 times 1, which is 1. And once again, we're going to be cycling through that same idea over and over and over again. So we're going to have I, -1, I, 1. I, -1, I, 1. And this will repeat itself all the way through. So the next one we're going to have, we don't even have to do the math. I can just do I to the ninth will be I to the 10th will be -1, I to the 11th will be I to the 12th will be 1. Not -1, 1. So it always cycles through. So every fourth power of I will be 1, and then it just keeps going through the cycle. So because 24 here, looking at this problem here, because 24 is a multiple of 4, it's simply going to go through the cycle and hit right there at 1. That's the same as I to the fourth, I to the fourth, I to the fourth 6 times. Well, what about I to the 75th? So we find the smallest multiple of 4 before then, which is I to the 72, multiplied by I cubed. Well, every exponential multiple of 4 is 1, multiplied by I cubed. Well, I cubed we just said was -I. So the answer is overall -I. Same thing here. We have I to the 31st. Well, we look for the multiple of 31, or multiple of 4 that's less than 31. So we have I to the 28th, and then we have I to the 3rd. So I to the 28th, again, every multiple of 4 in the exponent is going to result in 1, multiplied by I cubed, which is -I again. Then I to the 45th, well, then that means that's I to the 44th, multiplied by I to the 1st. So again, every multiple of 4 in the exponent is going to result in 1, multiplied by I, so the answer is I. So you can do any exponent you want of I simply by multiplying this through. So let's look at simplifying radicals with a negative under the radical. Now from a previous video, we know we can break this off into what I can take the square root of and what I can't. So if this was just 64, then the square root would have been 8. But what we have to break it down also now is into its imaginary items and its non-imaginary items. So the square root of negative 1 is always going to be represented by I. 64 is easy. That can be represented, the square root of 64 can be represented by 8. So I times 8, and we like to put the number before the letter. So that's 8I. Breaking this down, again, we have the imaginary portion, and then we have the real portion. But from a previous video, I can't take the square root of 28, but I can 128, but I can definitely break it down into what I can take the square root of and what I cannot. So, working it all together, we have the square root of negative 1, we have the square root of 64, and the square root of 2. So those are all the pieces that we're going to put in there. So the square root of negative 1, I'm going to go over this way, is I. The square root of 64 is 8. The square root of 2 I can't do, so we leave that underneath. And of course, let's put the 8 first before the I. Doing it again. Square root of negative 108. So we take out the negative 1. That's my imaginary component. And then I have my real component, which is the square root of 108. But again, this can be, we can actually separate this into what I can take the square root of. So let's break that down. This is going to be the square root of 36, and this is going to be the square root of 3. So we have all those components. I have my imaginary component. I have what I could take the square root of. Square root of 36 is 6. And then I can't take the square root of 3. So that stays under the radical. And let's put it in a nice, pretty order that makes mathematicians happy. Breaking it down again, I have the imaginary component. I have the real component. And then I've got this extra negative that's just part of the problem. Part of the original expression, excuse me. So the negative is this guy that was right here. Then the square root of negative 1 is represented by I, and the square root of 121 is 11. So putting it in a nice, pretty mathematical order, we have negative 11I. Now remember, when we want to combine radicals, they have to have the exact same base. So I can't put these two together. I can't say this is two of them because they do not have the same base. The square root of 16 is just 4. But the square root of negative 16, again, is the imaginary component. Oops, I put that negative on the outside. Is the imaginary component and the real component. So this is, oops, excuse me, I jumped the gun. That's 16 until I take the square root of it. Then it's I and 4. So we write this 4 minus 4I. And just like any other letter, we can't combine this. This is just a constant. This has an imaginary component. So we leave it like this. Do not combine it and say 0I or 8I or anything like that. Okay? So simplify both of these. I'll pause the video and go ahead and do it. So if you noticed, we broke it down into what we could take the square root of and what we couldn't. And in this case, and so that square root of 16 was 4. In this case, when I had here, we have negative 1, which is represented, the square root of negative 1, which is represented by I, the square root of negative 9, which is represented by 3. And so we have these two components. Now you can combine these, keeping in mind that we're trying to say they both have a common radical of square root of 3. So I will accept it this way, or you can also factor out the square root of 3 and say square root of 3 times 4 minus 3i. But again, do not combine the real component of the term and the non-real component. I'll take both of these as a matter of fact. So go ahead and pause the video and try these two values, or these two problems as well. Hopefully you got these answers. And anytime you're not, you can definitely send me a text or an email and ask me where some of your errors might be. So let's go down to adding and subtracting complex numbers. And this is the easiest part because you basically work with them just like you would any other variable. So there's just a plus in between, so the constants are in common, the i's are in common, so we're just combining like terms. The constants are in common, the imaginary portions are in common, so we're just doing like terms. And again, the same rules before. We have to distribute the negative. So now we have, again, the constants. We have the imaginary terms, and going from there. So this is also going to be the answer there. When we're adding these together, 3 and a negative 3, 4i and a negative 4i become 0. Again, 8 and a negative 6 become 2. 3i and a negative 4i become negative 1i, or just negative I. When we multiply, we have to remember that we're multiplying the coefficients, so 5 times negative 8 is a negative 40, and that I times I is I squared. Negative 4 times negative 8 is 32, and I times I is I squared. Now here's the difference. I squared, if you remember from the top of the page there, is that I squared is equal to negative 1. So leaving it this way is actually not allowed. So what I have is negative 40, that's my coefficient, and I squared is equal to negative 1. So this is actually equal to a positive 40. Same thing here, 32 multiplied by a negative 1, which is what I squared is equal to. So that's a negative 32. Now, when it comes to doing this, we know that we can multiply under the radical, but the rules are for radicals with that involve imaginary numbers, you have to evaluate them first. So this is I radical 6, because I can't, there's no perfect square factor of 6. But this one I can break down into the square root of negative 1, which is that I we took out, the square root of 4, and the square root of 2. So this one, I square root of 6, that's still there. But this one is square root of 4 is 2, so I've got 2i radical 2. So what I've got now is 2i squared, and I've got radical 12. We've got a couple things that can go on here. I squared, I said, was negative 1. Square root of 12 can be simplified. So that's of what we can take the square root of and what we can't take the square root of. So the 2 and the negative 1 is still there. We got negative, square root of 4 is 2. We don't need to write the radical again. And then we have 3. So putting all of that stuff together, all of this, we now have 2 times negative 1 times 2 is negative 4, radical 3. Let's multiply again, distributing. 2i times 3 is 6i. That doesn't need to be simplified. But 2i times I is 2i squared. And if you have any other degree or any other exponent on I, you have to evaluate it. So 6i, that stays that way, but that's plus 2 times I squared, which is a negative 1, or 6i minus 2. So do the distribution, do the FOIL method, and distribute all this out. So the first thing is to multiply and realize this is what we get. But when we have this now, I have 9, we have 59 and negative 59, which cancels out. Then I have 9 plus, that's 9 minus, negative 25i squared. Well, negative 25i squared is the same as negative 25 times negative 1. So this is 9 plus 25, negative 25 minus 1 is 34. So pause the video and go ahead and distribute. And make sure you simplify your I-squares. So the first thing we did is distribute everything out, but remember we can combine our i's. So 5i plus 8i is 13i, and then this is 4 times a negative 1. So 4 times a negative 1 is negative 4, so what I've got is the 13i, but I can combine that negative 4 and this 10 and get a positive 6. So the other thing to keep in mind, just like when we had rationalizing the denominator with real numbers, we also don't like having a square root if it's an imaginary number. So remember, this is the same as 6 over the square root of negative 1. Well, anytime we want to rationalize the denominator, we find the factor we can multiply to get this radical out of there. So if I multiply by square root of negative 1, then down below I'm going to have the square root of negative 1 times the square root of negative 1, which is just negative 1. So the radical's gone. But whatever you multiply by the bottom, you have to multiply by the top. So we have 6i essentially, basically here. And dividing, we can distribute that up and say 6i divided by negative 1 is negative 6i. Doing that again, I didn't need to convert that into square root of -1. I can simply leave it. Just wanted to illustrate it here. So if I multiply this by I, and I multiply this by I, we still are multiplying top and bottom by the same number. So on the bottom, I have -2 times I, so this is -2I squared. And then distributing this, I've got 4I minus 6I squared. So then all we have to do is simplify it. So -2 times I squared, which is -1, is a +2. On top, I have 4I minus, well, 6 times a -1 is -6, so we're going to add 6 to the top. And then old school simplifying, I can divide everything by 2. So this is actually the same as 2I plus 3 over 1, or just 2I plus 3. Now, if you remember rationalizing the denominator when we have a conjugate, we have to make sure that we use the binomial that will, well, I don't know why I put an equal sign. We have to make sure we use the binomial that will create the difference of two squares. In other words, we have to use the conjugate, or in this case, it's called the complex conjugate. So it's the exact binomial with the opposite signs. So I've got 3 minus I top and bottom. So distributing my numerator, I've got 24 minus 8I. On the denominator, remember, this ends up to be like the difference of two squares, so I will multiply it out long way one time. So I've got 9 minus 3I, we already multiplied this, then plus 3I, then minus I squared. So the top doesn't change, we have just 24 minus 8I. Here, these cancel out, -3I and a +3I, so what I've got on the bottom is 9 minus I squared, or 9 minus a -1. So I have 24 minus 8I all over 9 minus -1, or 10. And just like we did up here, you can multiply both, or you can divide everything out by 2 in this case to simplify that fraction. So dividing everything by 2, you're going to get 12 plus 4I all over 5. Pause the video and try this using the complex conjugate of this one. So again, the complex conjugate is the opposite binomial. It's exactly the same, except instead of plus, we write minus. If it was minus, we would have written plus. And so I FOIL the top and the bottom, and then we combine this out. Again, just keeping in mind that every time we see an I squared, it means -1. An I squared, it means -1. If it just says I, then we just use it like a variable. We don't go beyond that. Go ahead and do the complex conjugate on both of these. Remember, now that these are negatives in the binomials, you're going to need a plus in the middle of your binomial to get the conjugate. So there's the answer for that one. Keep in mind that, again, this was 2 minus I, so the complex conjugate was going to be 2 plus I, and then distributing these things through. Now we're going to use the complex conjugate of 12 minus 6I. Now some of you might have looked at that and said, hey, can I simplify all of that? And the answer is you can, but I'm just going to apply the conjugate and see where we land. So pause the video and work it through. Now I want to bring this to your attention real quick, is that if you'll notice for the top, I distributed 3I times both. But on the bottom, every time we multiply, and this should have been a plus, I apologize. Every time we multiply by the complex conjugate, the two middle terms fall out. So instead of writing plus 72I minus 72I, I just know that when I do the complex conjugate, we are going to be multiplying by, we're going to be squaring the first and then squaring the second, and it's going to have the difference in between them. So I just cut out that middleman. So this is 36I, and then remember, I squared isn't equal to -1, so this is the same as minus 18 over 144 minus 36 times -1, or plus 36. So we have 36I minus 18 all over, that's 180. And what's cool is you can divide all of these by 18. You can simplify a polynomial on top as long as you can divide every single term by the same number. So dividing the first term by I is 2I, excuse me, divided by 18. Dividing the next one by 18 is 1, and dividing the bottom term is 10, and that's your simplified answer. So now what we're going to do is we're going to see if we can combine any of these by simplifying the radical. So I'm going to scroll up to these ones and pause the video and work through it. So once we simplified, we realize that each one of these is a factor of I, and so we can go the 8i minus the 5i is 3i because there's nothing else here. And if you'll notice, I didn't make any I squares into negative ones or anything like that because these are all just single i's. I didn't multiply to get I squared. These are just addition or subtraction. So we can do the same thing here. This is going to be negative 2 plus, well, square root of negative 4. Well, it's the square root of 4, which is 2, with the I component with it. So we have this is squared. Now remember, anytime we square a binomial, with or without an imaginary component, you have to write the binomial out twice. You can't just simply say 4 and 4i squared. You have to multiply the whole thing out. So I'm going to write that all out and then square the binomial. So in doing these videos, or in doing these two problems, what we have is the 8, this is equal to negative 8i, and this is the actual end of this particular one. This is the answer here. But when you have any kind of fraction where every single term can be divided by the same factor, we can divide 8, these all can be divided by 4. So 8 divided by 4 is 2. This 4i square root of 2 divided by 4 is just I square root of 2, and the bottom 24 divided by 4 is 6. Go ahead and pause the video and complete these problems. Keep in mind it's easier to make them into their imaginary components before dealing with them. So the last of this problem is, remember, every time it's easier to take out the I component first. So the square root of negative 3 becomes I square root of 3. This one did not need an I component because there's no negative underneath the radical. So we have these combined to get this answer here. When we have this monomial multiplied by that one, we multiply our outside coefficients first, or we evaluate those, and then we also break down the inside. Again, if you'll notice, with the negative underneath the radical, I brought the I out. The negative underneath the radical, I brought the I out. And then square root of 5 can't be simplified, but the square root of 12 can. Now, I'm going to kind of put a line here to kind of distinguish. So then this final one here, the 4 times I squared means I had to stretch out the binomial. And then the 16 is here. The negative 4i becomes 8i. And then the I squared became negative 1. Don't forget we're subtracting this entire thing. So as I was expanding the binomial, I made sure it stayed inside the parentheses before I distributed the negative through. And then we combine like terms and we get 18 is equal to, 18 minus 12i.